When we talk about dilation of a function, we can talk about making things bigger, which is called a stretch, or making things smaller, which is called a shrink. But the thing is, it doesn't happen to the whole function all together. It'll either happen to the x, meaning a horizontal stretch or shrink, or it will happen to the y, which is a vertical stretch or shrink. So we're going to look first at the vertical, and we have a couple of test cases here. The first one is we're looking at what happens if you go from y equals x squared to y equals 2x squared. And I've graphed that for you using Desmos down here. That's desmos.com. Strongly recommend that you check it out. Alright, and so what happens is if you multiply the whole function by 2, you are doubling the y values. The x values stay the same. So this point here at 1, 1 simply goes up to 2, 1. The x stays exactly the same. This point here at 2, 4 goes up to 2 in x and double 4, which is 8, in y. So the y simply doubles. So the rule is the x stays the same and the y is doubled. Okay? This would be a vertical stretch. And you can see, if you look at this table, -2, -1, 0, 1, 2 for x, and for the y values, which we've called g of x, but whatever the function is, y values are going to be our original y values doubled. So instead of 4, we'll have 8. Instead of 1, we'll have 2. Double 0, still 0. Then 2, then 8. Okay, similarly, if we instead look at multiplying the entire function by 1/2, that's going to change all of the y values, multiply them by 1/2. So the x's will stay exactly the same, and the y values will go to 1/2 of their original value. Alright, so let's see what happens here. Our original point at 1, 1 is now at 1, about 0.5. Our point at 2, 4 is now at 2, 2. There's a point up here at 3, 9, and it's now at 3, 4.5. So everything has been shrunk by 1/2. This is a vertical shrink. And our table will look something like this. Instead of 4, we'll have 2. Instead of 1, we'll have 0.5. 0, 0.5, and I'm sorry, 2. Okay, so those are the vertical stretches and shrinks. The other possibility is horizontal, and that's where you're doing something to the x. Now, just like with translations, x doesn't work like we expect. Okay, so if we put the 2 in there with the x, so we're multiplying x by 2, and see that down here, let's look at what's happening to our points. So if we have points at -1 and 1, y values of 1, they've now gone, same y value, now has x values of plus and minus 1/2. Points at 2, 4 and -2, 4, those now have the same y value, but x values of 1. So the x is being multiplied by 1/2. And the y stays exactly the same. So counterintuitively, this is actually a horizontal shrink. Everything gets skinnier while keeping the same height. And this is true for any function. If you do these things to x in any function, they will react the same way. Doesn't matter if it's exponential or linear or what. Multiplying x by something is a horizontal shrink, whereas multiplying the whole function by something is a vertical stretch. Okay? And lastly, if we look at multiplying x by 1/2, let's look at what's happening at particular points here. So if we have our original points at plus and minus 1 in x, they are now, same y values, are at plus or minus 2. Plus and minus 2 in x are now at plus and minus 4 in x for the same y values. So what's happening here is that x is actually being doubled. So again, it does the exact opposite of what you might expect just from looking at it. So this is actually a horizontal stretch. Things are being pulled out horizontally while not changing vertically. And if we look at our table here, we're going to have x, y, and for the same y values, now instead of being at negative and positive 2, we're going to be at negative 1, positive 1. Instead of being at negative 1 and positive 1, we're going to be at negative 0.5 and positive 0.5. 0, of course, doesn't change.